Hey everyone, and welcome to this video. Today I'm Dan the Math Man with the Ways of Math, and we're going to be bringing yet another video on mathematics. Today's video is on synthetic division. This is the first of a multi-part series on synthetic division, and today we're covering the linear divisors. Okay, but before we get started, please be sure to subscribe to our channel and check out other videos that we have on there. Also check back regularly as we will be adding more videos up to come. Please be sure to comment if you have any comments or suggestions for future videos as well in the comments below. Okay, in this video we're going to describe what is synthetic division when it is used, the advantages over long division, and also some examples we're going to be performing so that you see how it works. In this video today specifically we're dealing with linear divisors. Okay. So let's get started. So first, what is synthetic division? So synthetic division is a technique that is used when doing division of polynomials. Okay. Now, one major technique of doing this, or one property of doing this, is to use long division. So synthetic division is a nice, clean way of doing it, kind of a more organized way of doing it, and I think in a lot of respects is a lot simpler. Okay. And the major advantages to it is because we don't deal with all the messy variables. We don't deal with all the x's and everything that we have with long division. We're just dealing with the coefficients of the polynomials. Also, we kind of pre-change signs. So if you're familiar with doing long division of polynomials, how we always have to deal with the subtraction of the polynomials, we actually won't be doing that. We'll be doing addition, which is really nice, and it avoids sign errors. Okay. So the types of synthetic division we're going to be dealing with today are with divisors that are linear. Okay, so divisors, this is our denominator of our division problem. Okay, and we're going to be dealing with the linear case. So linear divisors. Okay, now there are two types. The usual type that you see in most textbooks and you encounter in class are called monic polynomials, or monic linear polynomials. And monic polynomials are simply polynomials that have a leading coefficient of 1. So of 1. Okay, so the usual way of doing synthetic division that you'll see in class and in textbooks are only with monic linear polynomials. We're actually going to be doing examples of how to do it with monic linear polynomials like you would do, but also with non-monic linear polynomials. So this is linear polynomials that have a leading coefficient that's different than 1. Okay? As it turns out, synthetic division can be done with not only linear divisors, but actually with any order divisors. Okay? So it can be done for linear, quadratic, cubic, really any degree. Okay, and hopefully as we go through this series, you'll actually kind of get a feel for how to expand synthetic division into larger degree polynomial divisors. Okay, so let's get started with our first example. Alrighty, so suppose we have this example where we have x cubed minus 10x squared plus 19x plus 34. And I want to divide that by x minus 6. Okay, so we have our classic linear divisor down here that we see for synthetic division, and it's also monic. The leading coefficient here is 1. Okay, now the key to being successful with synthetic division is organization, making sure that your tableau, which is what you're going to see shortly, is organized. Okay, so this tableau you have these columns and rows. You want to keep these very clearly organized. If you don't, then synthetic division, as with any division algorithm, gets to be kind of tricky and you can lose track of where you're at. Okay, so how do we set up this tableau? So the first thing we're going to do is kind of set this up like this. Okay, so we kind of want to imagine that there's going to be like multiple rows, okay, to the tableau, and then multiple columns. Okay, so over in this top area over here, we're going to actually put the coefficients of the dividend or the numerator polynomial. Okay, and we want to make sure that every degree is represented. So just kind of like a placeholder. Even if a degree is not represented, we want to make sure we put it like a 0. Okay, in this case, we see that we have this cubic polynomial. Okay, so we want to make sure that from degree 3 all the way down to a constant, we have a place value represented. So for the cubic term, we're going to put the coefficient 1. For this square term, the coefficient here is -10. For the linear term, the first order term, the coefficient is 19. And for the constant, the coefficient is 34. Okay, so again, every power is represented here. Okay, if any power was missing, again, we put a 0 there. Alrighty, now what we're going to do with the divisor. So with the divisor, we're actually going to take this number here, we're going to change its sign. Okay, so this number being a -6 is actually going to be a +6, and that's going to go here. We kind of imagine that being in the second row here. Okay, alrighty. Now what we're going to do is we're going to end up with our quotient and remainder from our division down here in our tableau. A couple things to keep in mind. So this degree here is 3. We're dividing by a degree 1 polynomial. So our quotient is going to be a quadratic. Okay. Also, our remainder is always 1 degree less than our divisor. So if our divisor is a first order or a linear divisor, our remainder is going to be a constant number, 1 degree less than that. Okay, and then again, our quotient is always the numerator degree minus the denominator degree. So 3 minus 1 is 2. So we're going to have at most 3 terms here, okay, for our quotient, because it's going to be a quadratic, right? 1 term for the square, 1 for the linear, 1 for the constant. And then over here, we're going to put a little vertical bar to denote this is going to be where the remainder goes, this constant here. Okay, so now let's begin with the process. So we begin by taking this 1 and just simply bringing it down. Don't do anything with it, just bring it straight down. Okay, and then we take our divisor here and then multiply. So whatever we bring down this column, we're going to multiply. 6 times 1 gives me 6. And then we add the next column. So -10 plus 6 gives me -4. Multiply again. 6 times -4 gives me -24. And then we add those up. 19 minus 24 gives me -5. Multiply again. 6 times -5 gives me -30. And then finally add up the last column and we get 4. Okay? So again, right here is our quotient, and here is our remainder. So the quotient of our division is x squared. These are the coefficients of the quotient. X squared minus 4x minus 5. And then the remainder is just the number 4 because it's just a constant. Okay? Fairly straightforward, fairly easy to work with. Okay? Hopefully you've seen this before in class. Okay? And we can definitely do another example. So suppose we take the same example. So just to kind of see how this works again, well, we're going to change the number here. So from a -6, let's say we change it to 5, and let's see what happens. Okay? But it's going to be the same process. So let's do the same setup, but this time it's going to be, say, +5. Okay? So again, we're going to set up our tableau, okay, as we do before. We write all the coefficients, right, out over in this first row. 1, -10, 19, 34. Okay? We take the opposite of this number here, so this is 5, it's going to become -5. That goes, again, kind of imagine that we have a row here and a row here, so this goes in the first row, while the coefficients are in the second row. And then, again, keep in mind that we have a cubic divided by a linear, so the quotient is going to be a quadratic or second order, and then the remainder is going to be degree 1, so it's only going to have 1 term. So this last place here is only going to have 1 term. Here's another kind of shortcut to help remember that. However many numbers you have here is however many places you need to put this vertical bar for the remainder. 1 number means you're going to have 1 number for your remainder. Okay, so let's do the process again. Again, bring down the 1, straight down, and then multiply. Negative 5 times 1 gives us negative 5. We then add, again, here's the advantage of synthetic division. We add this column, negative 10 plus a negative 5 gives me negative 15. Okay? And then we're going to take 5 times a negative 5 times a negative 15. We get 75. Okay? And then we're going to take 19 plus 75. We get 94. Ooh, numbers are getting kind of big there. Alrighty. And then we're going to take the negative 5 times 94. And we're going to get negative 470. Okay, and then we add this up. 34 plus a negative 470. Okay, so 34 minus 470. And we get negative 436. So again, our quotient is going to be this here. These are the coefficients of the quotient. This is a quadratic. So x squared minus 15x plus 94. And then our remainder, that didn't come out so well. And then our remainder is this constant number here. So just negative 436. Okay? And so that's how this process works. All right, now suppose we don't have a monic linear polynomial. What happens then? So we're going to describe how we do this with a non-monic linear polynomial. Okay, so consider the example 6x to the 4th minus 13x cubed minus 25x squared minus 5x minus 21. We're going to divide that by 3x plus 4. Okay, so the tableau is set up very much the same way. We're just going to have an additional row to it. Okay, so we're still going to set up our tableau as normal. Okay, we're still going to write all of our coefficients from the numerator. Okay, make sure you write them in descending order and make sure that you don't miss a place value. Right, this is the time it's a 4th degree polynomial. Okay, so we want to make sure we have the 4th coefficient, the 3rd coefficient, the 2nd coefficient, 1st coefficient, and the constant number. Okay, represented. So we're going to have 6, negative 13, negative 25, negative 5, and lastly, negative 21. Okay, again, organization is important. We want to make sure that all these things are lined up very nicely. Okay? Alrighty, now we're going to do the same thing here. Take this last number here, this 4. We're going to change its sign. We're going to make that a negative 4. Again, they'll line up, right? So our coefficients are in this first row. This is going to end up being in our second row. We're going to actually have 2 rows down here, okay? So the first row is where the sums go, but then we're going to, this is the thing that's different with the non-monic, is we want to divide whatever we get in this row by this leading coefficient. So we're going to divide by 3 there, okay? And then again, we have a 4th degree polynomial. We're dividing by a 1st degree polynomial. The result will be a cubic or 3rd degree polynomial. And our remainder is always 1 degree less than our divisor. Since our divisor is a linear, we're going to have a constant remainder. Okay? So again, we're going to notate the remainder by this little vertical bar here. So this area over here, this last column, the sum there is going to be our remainder. Okay? So let's begin. It's the same basic process that we just did. Bring the 6 down. Okay? The difference here is whenever we bring down the number, we then divide by 3. So the 6 divide by 3, I get 2. Now it's this number that I multiply by. So negative 4 times 2 is what goes in the next column. Okay, again, negative 4 times 2 gives me the negative 8. I then add this column up, so negative 13 minus 8 gives me negative 21. Again, then divide by 3. So this second row down here is being divided by 3. So negative 21 divided by 3 gives me negative 7. Okay, again, nice clean columns. Make sure we keep our clean columns. Then we take the negative 4 here times the negative 7. We get positive 28. Then we add that column. Negative 25 plus 28 gives me a positive 3. Again, divide by 3. We get 1. Again, multiply. Negative 4 times 1 gives me negative 4. Add that up. Negative 5 plus a negative 4 gives me negative 9. Again, divide by 3. So we get negative 3. One last multiplication here. Negative 4 times a negative 3 gives me a positive 12. And then lastly, negative 21 plus 12 is negative 9. Now, since this is our remainder, this does not get divided. Only the quotient coefficients are divided by 3. The remainder is left alone. Okay? So, fairly quickly, we've seen that the quotient here, now remember this is a cubic, right? We have 4 terms. This is a cubic polynomial. As we said earlier, exactly what we expected. So 2x cubed minus 7x squared plus x minus 3. There's our quotient there, right? Our coefficients of our quotient. And then our remainder is negative 9. Okay? I hope you enjoyed this video. I hope this was informative. Again, please leave comments and suggestions in the comments below. And I hope you enjoy and continue following. And please subscribe as we'll be adding videos. Thank you so much. Have a wonderful math-filled day.